Welcome. This video is about simplifying IP version 4 using binary. But before we get started, it is important to understand that we have two choices when it comes to networks or computers and how things work. You have an analog choice, which could be represented by a wave, or we have a binary choice, which is represented by a series of on and offs, something similar to this. Now, you may ask yourself, why do we choose binary over a wave? Well, first of all, it's important to understand that a wave is very complex. In other words, you can imagine a clock and look every place along this wave infinitely. I can divide this up. And if I was using a computer in order to process my exact location, what you'd find is I would need a tremendous amount of processing power. So for instance, you can see I'm only using this, but I would have to go in and calculate. Look, if I just divide it up infinitely, I would have to calculate this point, this point, this point, this point. This is very accurate, but at the same time, it takes a lot of processing power. So computers it would be better to use a series of on and offs. And this is how all computers communicate with each other. So it could be represented in two ways. It could be represented if you're at the low part as a off, and we would represent that as a 0, or on, it is a 1, or an off, and an on, and an off, and an on. Oh, sorry about that. A off. Yep, this is an on, yep. And anyway, in the bottom, this is a off, and an on, and an off, and an on. Okay, so in other words, when you look at this, what I have is 0, 1, 0, 1, 1, 0, 0, 1, 0, 1. Now, unless you're a Rain Man, this is not really human readable. So what you have to get and understand is that you have to learn how to take binary and convert it into a decimal number. And so this is my attempt today to explain to you how to do that very simply. So I have to tell you a story. I'm going to erase this. It's not the easiest thing in the world to erase, but it's important that I tell you a story about a friend of mine called Peter, and his father sold bricks. His name is John. So this is their business that they opened up. And this is John's brick store. All right? And what he did was had a series of bricks. First of all, let me put John inside of his store behind the counter. Here is John. He's happy. He's got smiles. And here is his son, Peter. Peter's going to find out he's not going to be very happy after a while. So they're selling bricks. So the very first day they opened up for business, imagine this is a road. It's kind of a weird road, but anyway. Everyone came in. And he had customers the very first day. The first customer said, look, I want 10 bricks. The next customer said, I want 16 bricks. The next customer said, I wanted 128 bricks. And so what John did was told little Peter, hey, out back, we have stacks of bricks. We have stacks of them. They're on pallets. Not necessarily organized, but there are stacks of them. So what I want you to do is, he told little Peter this, what I want you to do is go to the stack and bring me 10 bricks. So what Peter did was he went to the stack and he grabbed a brick. And then he took it to this guy. And then he went back to the stack again, and he grabbed another brick. And he took it to us. By this time, this guy is sweating, right? Because he sees that this doesn't make very much sense. So let's do it a different way. He had a much better idea on how he could do it. He told his dad, look, Dad, sorry about the erasing again. He said, look, Dad, what I want you to do is I want you to organize these bricks in a way that makes better sense and makes me not work too hard. So he said, Dad, what I'm going to do is I'm going to create a palette. 1, 2, 3, 4, 5, 6, 7, 8. He said, I'm going to create 8 different palettes. But on each palette, I'm going to put a different amount of bricks on it. So on one palette, I am going to put, here, let's do this, 1 brick. The next palette, I'm going to put 2 bricks. Next one, I'm going to put 4 bricks. And I'm going to put 8 bricks. And I'm going to put 16 bricks. Next one, I'm going to put 32 bits. And I'm going to put 64 bricks. And I'm going to put 128 bits. Right? And if I only want to think about this, it's very simple. He says, Dad, if you want 10 bricks, what I'm going to do, I need you to do is buy me a wagon. And I want you to buy me a wagon so that I can pull it with the bricks that you flagged. So the first group of people wanted 8 bricks. So I wanted 10 bricks. So I would want you to put a flag here. And I want you to put a flag here. So at the same time, I want you to understand is you have no bricks here, 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 no bricks here. And so when you look at it, I only have 2 pallets that we need to pull. And so if I pull this one and this one, I'm going to get your 10. Dad thought that was a good idea. And look, here's how it goes as well. If I wanted to get 16 bricks, like you want, all I have to do is put a flag here. This is very representative of binary. So just think about it. This is a 8-bit number. So when I look at it, it's going to be when I write it, it's going to be a 0, 0, 0, 1, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, or equals 16. So what you have to understand is that binary is not human readable, but they all have a decimal representation of any number that you can possibly create, no matter how big it is. It just depends on how many placeholders you want to actually use. For now, this is the very first stage. Next, we're going to look at how this is represented in a IPv4 network.